Gustavo is trying to guide Stefan in. Okay. Thank you for your patience. This is our first experience. I think we will be relogging Stefan. We can see you. Okay,
okay. Good.
Share your screen and then we can.
All right.
Yeah.
So.
Good. In a minute. Cool. Okay. All right, Stefan. I turn myself off and you please go ahead.
Okay, thank you, Tanya, and sorry for the problems, but it took me a while to find out how I can actually activate my system here. Yes, my name is Stefan Krüll. I'm joining from Austria, Vienna, and I would like to introduce you within the next 15 to 20 minutes to how we are using blockchain for the mining, or actually for the metal industry. Let me start off with one thought. So the Internet of Things will not only dramatically change the way we look at manufacturing, but also the world of materials, such as of steel, which is also my personal background. I joined the steel industry almost 2 decades ago, and was a managing director of one of the leading European steel distribution companies that in the late 80s enlarged its activities into the region of Central and Eastern Europe. So basically what is nowadays Central Europe. For those of you who are not so familiar with the steel industry, let me give you a short introduction. So steel is not only the key material to many of the industrial sectors in Europe, and I would say backbone for the globe, in general, backbone for development globally, but also plays a very important role in our everyday life. Did you know that each of us in Europe consumes almost 1 kilogram of steel per day? That is surprising, but when you think about it, I mean, we all use public transport, we all work and live in buildings that are also contain steel materials. But there's another resource that is becoming far more important, which is data. And 3 years ago, this article just blew my mind. And ever since then, I was kept with the question of how to actually tap the value of data for the steel and metal industry. I started my journey doing some research on what's actually driving the metal processing industries right now. So basically my former customers, which are companies from the mechanical engineering, machine building, and steel construction sector. And what I've learned is that the #1 topic there at the moment is automatization and connecting equipment, connecting machinery in order to enable smart manufacturing. And there are studies that say that in only 5 years from now, there will be probably 10 times more machines connected to the internet than there are humans on the planet. So the question for me was that if we are now connecting the machines to the internet, where steel is being processed, so what about the materials that are being processed on these machines? How are they being able to, how can we address them in a digital way? Yeah. And today we provide the information, the quality information regarding metallurgical products and steel, basically on documents by so-called mandatory inspection certificates. So that's paper. Yeah? That's paper that's being handed over together with each shipment of materials. And in these papers, parties or steel producers basically certify the compliance with relevant standards, but also these papers carry important material properties and all the relevant test results. And when I did my research, I just started to understand what numbers we are talking about. Yeah, so only in Europe, it's around 100 million certificates that are being created, exchanged, and stored every day. And of course, with a huge disadvantage because all that data still is not machine readable. And this is exactly what we are solving with SteelBot Smart, our company. So we provide the physical material a digital identity that travels with the physical metal, so that companies can replace basically these paper certificates with traceable, tamper-proof digital records using the blockchain. In order that this data is then maintains to be available, yeah, for instance, to be used for smart manufacturing, but also in future to assess carbon emissions. And here the value is not only to digitize the paper-heavy process that I illustrated before, but also to enable entirely new business models that are built around the idea of the combination of quality data with a digital identity. So at the end of the day, we could say a digitally enriched material or a digital asset. The way we approach this topic from the technical side was basically in 3 steps. So first of all, we had to completely rethink the architecture of how this data is actually kept. Yeah, we had to think of it as a shared data layer that serves as the industry's single source of truth, because so far each party keeps its own data in its own silos. And the target, of course, is to make this data available in a decentralized network where each party first maintains full control and ownership of the data, but the data can be also shared in a trustworthy manner across company boundaries in a peer-to-peer way. The second thing we had to change is the way this data is captured, recorded, and stored at the end of the day. So what we developed technology where at each step of production we can capture the processing data, we can capture the testing data, we can keep it in a digital format using the blockchain to ensure tamper-proof recordings, but still meeting document standards. And at the end of the day, what is also important, to find a way to support various tagging technologies, because we also need to identify the physical product in order to keep the connection with the digital twin. And here we're using technology of our co-investor, an Austrian-based company called Riddle & Code, that specializes in creating trustworthy connections between the physical world and the digital world. And this is technology that has been used already in a number of other projects and use cases in other industries, like the banking industry, like the automotive industry, and the telecommunication. The third step that we had to think of is we had to come up with a plan of how to that could actually work to migrate an industry like the steel industry, which is a very big and very complex and globally fragmented industry. And the idea here is that such a migration can only work in a number of steps. So we started off as the status quo that I mentioned before, which is paper. We developed a very easy, let's say, staging product that enables to, provide the data not in a PDF format, but in a JSON format that we hash on the blockchain. So that brings one immediate advantage. So the data is machine readable. And the second step is then, of course, to provide the data in the form of a digital asset. So at that stage, we have to really tokenize steel. And the third step will be that we also have to secure basically the source of the data. This is where the machine identities and the secure elements that I've showed before come into place. But I don't want to talk too much about the technology concepts. I would rather like to show you how that could actually work and how that could actually look from a user point of view. So I will introduce you to one of our demo systems. So here we are in a role of a steel factory, as you can see. And let me just start this presentation. So in a steel factory, you have a laboratory. You have basically, you can provide additional inspections to the physical material. You have a section where you can see the certificates that you have issued, and you have a section where you see the goods that you've issued. So what we do is that with each, let's say, when we produce physical steel, we get all the quality data of the material. So basically, that's the chemical composition that is provided with the melting of the material, and we provide this information to our blockchain solution. And at this moment, we create a digital asset. Yeah, we create at that example, it was 124 tons of steel with a dedicated chemical composition. You can see the transaction on the blockchain. And at that moment, we have created digital metal, so to say. Yeah. In the next section, I can show you that we can add any additional information to this digital asset. So in that example, I will add a certain carbon footprint to it that is then connected to this batch of material. Once the material is being created, the next step is to sell the material. Yeah. So here we are moving from the steel factory to, we're staying in the steel factory, and we basically go to the goods issued section. And if we sell material, we basically record the data of delivery nodes. So in the delivery nodes, we understand who is the customer, what is the batch of material that has been sold. Yeah. So we load one of our delivery nodes to our system, which is being done right now. And what happens here is that we split the digital asset. Yeah. So part of it stays within the steel factory, and another part, in that case 12 tons, are moved to the customer. Yeah. You can see again the transaction on the blockchain. Yeah. And all the metadata, like all the quality data that is connected to the original batch, is now used in the certificate. So now we can see that in the certificates issued, we have provided a certificate for the customer that contains all these material properties and quality information. So, yeah, and here you can also see in the goods issued section. So this way now we move to the customer, and in the goods received, certificates received section, now you can see that he has received a quality certificate related to that batch of materials. Also with this dedicated carbon footprint that we have added before. So this is how we track quality data along the supply chain. And the drivers that we see for such a solution are basically three main drivers. So first of all, it's the topic of traceability. So we have more complex product designs, we have more complex technologies, we have a globally fragmented supply chain. And that means that there is rising awareness of safety, and that means also that the standards for traceability are continuously increasing. You have on this picture, you see a bridge, and for such a bridge, you have for each nut, for each bolt, basically you have to provide full traceability of the material back to the source. The second driver is digitalization. We already talked about it before. I would say it's more adaptive process control. So the idea is that with these digitally enriched materials, they can connect to machines these materials can mandate machines actually for optimized processing setup during manufacturing. And the third topic is decarbonization. Steel and metals are often recycling champions, but they have a carbon problem. The European steel producers are committed towards a decarbonized future. So by 2050, steel, what they want to achieve is actually a decarbonized production of steel and metals. And that, of course, means that this development will have to be supported by political framework conditions that ensure a level playing field for the European producers. So what is being discussed is initiatives like the carbon border adjustment mechanisms to avoid carbon leakage. And that, at the end of the day, means that what we need is a trustworthy assessment based on what's actually sustainable produced steel and metal and what's not. And this assessment base you don't need on a factory level, but you need it on a batch level. Because besides governments, there's also more and more industries and industry leading business organizations that are driving the need for more transparency regarding carbon emissions. So in that example, you see that the automotive industry is no longer only looking towards the emissions in to the exhaust emissions of their car fleet, but they would also like to understand what is the carbon footprint of all the materials and parts that are being used in a vehicle. Yeah. So the question of traceability is no longer one of just raw materials, but it's one of the entire chain. It's one of the entire supply chain. And this is also one of the use cases and pilot projects that we are working on. So we are tracking for an automotive supplier quality data and carbon emissions. So from the raw material up to the various processing stages, up to the part that is then being used in a vehicle. So what I think is important, and also what is especially important for companies out from the mining space, is that if they are working on projects to make their sourcing and production more transparent towards sustainability, is that to integrate these initiatives and consortia also with other parties that are more further down the supply chain. So as the example that I've showed you before, because what I've shown you before is that we are focusing on the downstream processes, starting from the smelter, basically from the steel production plant, which is illustrated here on the right side of the slide. But of course, we would like to invite companies from the mining space to also use our technologies and solutions, or to connect ongoing projects, because at the end of the day, if we make these different projects and consortia interoperable to each other, we can achieve the mission. So at the end of my presentation, I want to leave you with one more thought. The complexity of the steel industry and actually the lack of data processing standards, of course, also creates increasing opportunities for fraud and forgery. And today, with the use of blockchain technology, this can be avoided. So I hope I gave you a short insight now of what we are building and why we are building it. We are convinced that we will change the industry, and there is a pain, we have a solution, and we have the technology to make this change happen. Thank you very much.
Thanks a lot, Stefan. That's great. And thanks for showing us the inside workings of the blockchain, because it can be very scary when you don't actually see what it looks like, which is just like, just a very simple text, really. It is indeed a database, or distributed, but you don't need a spaceship to run a blockchain. So yeah. I think that's great. Thank you very much. Really appreciate you sharing your expertise. And indeed, I think mining companies can learn from your solution. So I hope we'll stay in touch. Okay. And I'm very glad to introduce our next speaker, my fellow Canadian, Nathan Williams. Nathan is with MindSpider, which is a startup in Berlin, and he's joining us from Berlin today. I first met Nathan in Berlin, where he kindly invited me to be on an expert panel for blockchain in Africa. That was already more than 2 years ago, and since then I was amazed at the progress that his startup has made in developing the blockchain technology for various areas in the mining industry. And I watched his often LinkedIn posts and podcasts. So yeah, Nathan, welcome and thank you for joining us today. And please go ahead.
Absolutely. Can you see my screen yet? Everyone?
But we see too much. No, that's good. Yeah, that's good now.
That's good?
Yeah, yeah.
All right. Perfect. Thank you, everyone. Thank you for having me here. There have been really good presentations so far, and I really liked what Stefan had to say in his presentation about the importance and how we can actually get sustainability in the mining supply chain. And I want to spend a couple minutes to talk about why. My name is Nathan Williams. I'm the founder and CEO of MindSpider. So we're also doing a blockchain for the mining industry, and we are using what is known as a public blockchain, which Andy explained earlier, in order to connect different regions, different mines who don't necessarily trust each other to help them share data. So one thing that happened earlier this year is we saw a big shift in the mentality of the investment market when Larry Fink at the World Economic Forum declared that they would be looking at sustainability as a new standard for investing, and where the biggest investor goes, the rest will follow. We're starting to see this shift in how the money is moving toward more sustainable products. And this opens up opportunities, but it also means that there are threats. This is going to be top of mind when people are purchasing. They want to know where our materials, our products coming from, and under what conditions they're being produced. And now is the time when we can go in and say, well, we want to be part of this global shift. And we're already seeing this starting to happen. Earlier this year, the London Metal Exchange announced plans for trading of low-carbon aluminum, for example. And this is a landmark moment because aluminum is a commodity. It is something that you buy and you sell based on the current market price, and that's it. And this move is a first step in decommoditization. And we've seen some other companies also move in that direction with tin, with gold, and we believe that there is an opportunity there. So there are regulatory pushes to knowing where your materials are coming from and under what conditions they've been produced. But that in itself is not a strong enough force to move the global economy. It is the instigating factor, but the real driver behind this is people believing they have a right to know what they're buying. And up until now, responsibility has always been pure cost. So this means that mines and smelters who have done extra due diligence, who have paid their workers fairly, who have put in waste management policies and undergone their ISO 14001 certification to make sure they're not polluting the environment, are at a cost disadvantage. And if they wanted to sell at a premium, they would need to talk to not the low-level traders. They would need to talk to the CEOs of the companies who would purchase from them. And it was very, very difficult up until now because there is no way to actually distinguish metal that has come from a responsible source and metal that has been mined using forced labor or metal that has had other illicit practices contribute to its production. So about 50 odd years ago, it was legal and normal to sell pharmaceuticals anonymously. And that changed, and people complained, and people resisted that change. But nowadays, no one would ever think of selling a pharmaceutical without knowing the conditions under which it was produced. 20 years ago, this happened in the wood industry as well. I think we're at the point where we have the technology to say we can track and trace and know where our metals are coming from, and maybe this should be normal. Maybe there is a future in which metal is not sold anonymously. So the way we've approached this is similar to how others have approached it. We use blockchain to create digital certificates. Now, the certificates are stored on the blockchain, and the way I like to explain how the blockchain works is it's essentially just a database. It's not rocket science. It's a database that is copied 1,000 times. And everyone who participates in the database has a copy of the data that is stored on it. This allows you to know for sure that what the original version of the data is. In a sense, it lets you create unique digital items. Now, if you think of a digital item, you think of a sound file or a movie that can be copied 100,000 times. But what if you knew which one was the original and which ones were the copies? Well, then that digital item could store value. Most people think about Bitcoin when they think of blockchain because those digital items are coins. They can hold financial value. Well, what we're doing is we're creating digital certificates, which can't be copied, where you can know which is the original. So what this allows you to do is to put data in there that can't be changed. And it can engender trust in an area where you might not have trust otherwise. The way MindSpider works is that every member along the supply chain creates a digital certificate that gets linked to other people's certificates. So this can be used both to map company level information, such as your responsibility policies, your ISO certificates, or materials level information, such as a unique identifier on a pallet of metal and the origin of that pallet and the current location and shipping routes. So we have data that can be tied to companies, allowing people to make more informed decisions. Right now, it is a pure cost, but as this becomes normal, as the big players adopt it, it's become simply a cost of doing business, and it levels the playing field. And so that's why we believe that this is a future that we are nearing the tipping point of achieving. So let's imagine you want to adopt some blockchain in your mind. Well, what questions should you ask before starting? We've been approached by mines and smelters and non-mineral companies from all over the world who are interested in using blockchain to know more about their supply chain. But there's always been this problem of they want to know more, but they don't know what they want to know. So the first question to ask is, what kind of data do we need to capture? What would deliver value? What would help us know more about what we're purchasing or what we're selling? Then the second question is, how can we balance this trade-off between transparency and privacy? If I'm sharing data, especially on a public blockchain, I might not want my competitors to see where I'm purchasing from. I might not want the customers of my customers to know where I'm purchasing from. There may be trade secrets that need to be stored on a blockchain so no one can change them, but hidden so that only the right people have access to that information. So these are dangers on the right road. The third question is, how do we address specific issues such as human rights abuses in the supply chain? What data do we need to gather? How can we address this. And it can be, for example, if you want to address the issue of child labor, maybe going and auditing isn't enough because an illicit actor might hide whoever is working there one day when the auditors visit. Maybe there's other data, such as school roll calls, that you can observe to get a better picture of what's going on. This all comes down to that question of how do you avoid the garbage in, garbage out problem. If people put fraudulent information on the blockchain that can't be changed, it doesn't really help. And so there has to be a lot of thought that goes into what risks we expect at which point in the supply chain and what data we can collect in order to mitigate those risks. So the way we approach this is, first of all, we've developed our own infrastructure. You can think of a blockchain infrastructure a little bit like the internet, sort of like Andy said in his presentation. It's a way of encrypting and transmitting information. And then on top of that, you can build different applications. And so what we did is we built our own blockchain infrastructure for creating these certificates and linking them together. And then we can build on top of that any number of applications that might tell you all the information you need for certain regulations. It might be able to tell you what the chemical constituency is of your materials, so you can authenticate it, or you can prepare certain processes in advance. There are any number of applications once you have the core structure in place. What we did in order to manage this in a blockchain where everybody has who participates as a copy of the data is with what's called layered encryption. So what we do is a blockchain certificate is created with 3 different layers. A layer that is visible publicly, which would have information about what type of certificate it is. Is it for tin? Is it for lead? As well as hashes or encrypted versions of the layers beneath. The transparency layer will be visible to everyone who is linked together in the same supply chain. And this will contain information such as compliance information, information that helps companies know that the material is correct. The digital fingerprint could be contained in the transparency layer. And this layer is encrypted with a key. And then the encrypted version of the transparency layer is stored in the public layer. So anyone receiving the transparency layer can know that it is unchanged, even though only the key holders can read it. Finally, we have a private layer. This layer is only visible to a company and its immediate customer. And it is encrypted with a key. Everyone will, in the same blockchain, can see the encrypted version, but they cannot read it. So they can verify it is unchanged, even though only the key holders can read the information. By dividing the data in this way, it allows us a lot of flexibility in how we create, permission, and store this data, even though there's no single entity, no single company in charge of the supply chain. That's how we've approached this. So we've got a couple of ongoing projects that we've done. One is in tin traceability. We've had Google involved with that, and Volkswagen, and we've tracked tin out of Minsur San Rafael mine in Peru to end participants. And we've identified the documents that are necessary to authenticate the information, stored them on the blockchain. And we've also done a project with Volkswagen in lead battery traceability, starting at the other end of the supply chain and moving backwards, seeing who is present in the supply chain and what policies they have for worker safety. And by doing this, what we recognize is that it's really, really hard to get a project where you have to have the cooperation of many large companies. And so that's why we're developing right now a new application that will sit on top of our blockchain called OreSource. OreSource is going to be a blockchain app that gives value to a single entity, a smelter or a mine, that captures everything they need to be able to sell it into Europe to help their customers. Because Europe has their new European conflict minerals regulation coming into force in January 2021. And the idea is to have a simple QR code that adds value to the metal that you're selling, so that when your customer purchases it, they have everything they need to do the due diligence and to say, we've done what is necessary to comply with European conflict mineral regulation. By doing this, what the mine or the smelter gets out of it is they have a way of distinguishing their products from the world market. It's not just a commodity anymore. It is a product that comes with a distinguishing mark. And this is sort of an example of how a screen would look like, is that you've got the European Conflict Minerals Regulation with certain data that you can attach. You can see you could also add in carbon emissions in this case, because what we've done is we've built this templating of information that can be then attached to the material. So that's just a little bit of what we're doing here at MineSpider. Hope to give you a little aspect as to where we see the world going and why you might want to use blockchain in the first place. We really believe that, that the days of anonymized mineral sales are numbered, and that the future really is going to be trusted products, that your products are more valuable because you know where they came from. And so thank you for your time, and I hope I can answer any questions you have.
Thank you very much, Nathan. Yes, there are questions. If you can answer them really quickly, I'll read out to you. Could you please give us example what associated information usually is provided with the digital certificate?
Absolutely. So the most important thing is it depends on what problem you're trying to solve. Right. So if you're doing OECD due diligence guidelines, which is what the European Conflict Minerals Regulation is based off of, most important is location and origin. Where is it being transported through? And digital identifiers. So if you've got, for example, tin, are there any marks that will distinguish it on the, are there any trace elements that, I almost said impurities, but trace elements that would serve as an identifier so you could authenticate that this material you've received is what you were sold. There are, in other materials, that might not be as important, especially if you're starting at a brand and moving backwards. Many downstream companies, such as manufacturers, auto manufacturers, are more interested in the policies of the companies that they're buying from. And so, if you're buying an auto part, maybe traceability of each gram of material is less important than who am I buying from? Do you have conflict mineral policies? Are you doing this due diligence that we want you to do? Do I have reason to trust where I'm purchasing from? And can we see sort of a map of who you're buying from, where all of this is coming from, and are we at geopolitical risk or are we at supply chain risk? Does that make sense?
Yeah, absolutely. Yeah, and there are more related questions, but unfortunately we're pressed for time today, and this is why I want to continue this conversation, with you later in our LinkedIn group, and I probably will also start a little newsletter where we can, discuss more, because people are asking very basic questions that we also have. How do we ensure? There's a question, how do we prevent a mine from reporting they're producing more than what they actually extract in order to create space to include minerals mined illegally? Are there any experiences and what are the main experiences and difficulties you can share related to the project with Volkswagen? So there's a lot of interest. I think it was a great presentation, like really calm. Obviously, you know what you're doing. You're feeling comfortable now. You really, advanced beyond the very beginning. So this is great. This is just great to see. This is how we want blockchain in mining to start and progress for the benefit of all, of the miners, of the consumers, and mining has a bad, reputation with many people, and a project like yours are exactly what is needed to show that what we're doing is, clean and good. So that's great.
Yeah, what I can do is I I can take a few moments and type in some answers in the public chat, and then if anyone has any follow-ups, they can connect with me on LinkedIn.
Yeah, and also we will have a follow-up, which I hope you will join us for expert panel from 1:30 till 2. So maybe we can talk a bit more then as well, okay?
Sounds good. All
right, cool. So our next presenter joins us all the way from deep lockdown in Melbourne, Australia. Michelle Ash is the CEO of Geovia now, which is, of course, a company that provides services to the mining industry from resource modeling through to mine optimization, and now all the way to shipping even. Michelle is watching us today, but she will not be presenting because of the internet connection quality. We do have a recording of her presentation, which I hopefully will be able to turn on now. Let's see how good I am at that. Okay. All right.
Our next speaker is Michelle Ash. I first heard Michelle speaking at Indaba conference in Cape Town, where I was fascinated by her idea of not mining gold, but leaving it in the ground and evaluating it as in the ground resource. I later heard excellent